glue. Now, raise your hand if you think that this is the oldest trick in the book. All right? You may not realize how old it really is. Tammy, the trick that you and I are about to do was first done by a Greek named Thales of Miletus in 600 BC. Now, of course, they didn't have balloons back in ancient Greece. Instead, our word electricity comes from the Greek word for amber, fossilized tree resin, electron. Because when Thales rubbed amber up against fur, he discovered a force between the two. Tammy, we now know that force is the electric force, and what makes it a thing called electric charge. You and I are about to show all these folks that electric charge is not just in batteries, it's in everything. And to show you that, we're going to use the electric charge in this balloon and in Tammy's hair. Now, you probably remember that everything is made of these teeny tiny things called atoms. And although they're way too small to see, we now know that there's positive charge on the inside of every atom and negative charge on the outside. Both kinds make the electric force, but each makes it the opposite way. And since usually there's equal amounts of negative charge sitting right on top of the positive charges, the pushes and the pulls cancel, so we don't notice the electric force. What we're going to do, Tammy, is separate those electric charges. We're going to put the negative charge in one place and leave some positive charge behind so we can see the effect of the force between the two. I'm going to give you a mirror so you can see the results of our experiment. I want you to hold that with both hands. Take a step forward so that everyone can see you. We're going to zoom in even more closely so we can see the results of our experiment. And Tammy, I'd like to ask you if I throw this balloon against your hair. Would that be all right? All right, excellent. Now, whenever we put different materials in contact, we can separate electric charge. In this case, I'm going to take negative charge off of Tammy's hair and put it on the balloon. That's going to make the balloon negatively charged, and it's going to leave Tammy's hair positively charged. And once we separate those electric charges, that's going to give rise to a hair-raising electric force. Now, Tammy's hair is standing on end, but did it change color?
No.
Is it making any sound?
No.
Is it electrified?
Yes.
I've just proved to you that electric charge is invisible and silent. That even though it's invisible and silent, we can clearly see that opposite charges are attracted to one another. Because Tammy's positively charged hair is attracted to the negatively charged balloon and follows it wherever it goes. We can also see that the strength of the electric force gets weaker the further the charges are apart, because as I bring the balloon away, gravity pulls her hair down, and it gets stronger the closer the charges are together. Because the closer I bring the balloon to Tammy's hair, the more of it stands on end. These are effects between